Hi everyone, let's solve today's daily challenge, that is minimum common value. So in this question we are simply given two arrays, nums1 and nums2, which are sorted in non-decreasing order. Non-decreasing order means increasing order. And we need to return the minimum integer common to both arrays. Okay, and if there is no common integer, then you have to return -1. Alright. So let's see what the question is. The question is quite easy, that you are given two sorted arrays, and inside of those sorted arrays you need to print the value of the minimum common integer, right? So there can be several common integers here. See, to both the arrays you can see you have 2 and 3, which are common to both arrays. Now, out of them, which one is the minimum? 2. So you have to return 2 in this case. Now, let's say you had arrays in which there was like this intersection array came out to be nothing, right? There is no element inside of this array, then you have to return -1. All right. So I hope you've understood the question now. Now, let us go ahead and see how to solve this question. So, one very brute force solution to solve this question would be, we're discussing the brute solution right now, is simply iterate on nums1, nums2. Let's say the nums1 is n length and nums2 is m length array. And what you'll do is you'll iterate from integer I to n, that is iterate in this array, and then also iterate inside this loop from j to m, right? 0 to m, okay? 0 to n. So you'll iterate like this. So you will keep checking if this particular element, right, is equal to any element in the array. It is not. Move on to the second element. Is this element equal to any element in the array? Yes, it is, which is 2. So you'll return from there. So this is the brute force, but here you can clearly see the time complexity will be big of n into m, which is like huge. And if you try to do this question in this, you'll get TLE, right? All right. So what can be the second approach? The second approach could be, this would, I would say, a better approach using hashing, right? What you can do is hash the values, right? Hash the values of nums1 and nums2. Okay, now what you have to do is you have to only hash those values which are common to both the arrays, right? So what you'll do is you'll start from 1, right? Put it in your map, put it in your map. And also what you can do is you can get a pair, and you can say this is coming from the first array and the element is 1, and take another pair. So like this you can store the values coming from the array 1. So, and after making this hash map, what you can do is compare it with the, also make a hash map for this, or rather store in this particular hash map only from this also, and then simply iterate and check what are the pairs that have the same elements, right? Pair might be having, it is coming from the first and also from the second array, so you will get 2 and 3 in that case. And from here you can see, you can simply iterate here and find out the minimum one. Okay, now let's discuss the optimal approach to solve this question, right? If you are not beginner, you will never go to these approaches, right? Reason being, you are being told you are given sorted arrays, right? You are given what? Sorted arrays. Okay, we are given sorted arrays. Okay, with intuition, we know the minimum integer is going to be from starting from the 0th index, right? So you have to simply check. Here what you need to print? Minimum integer common to both arrays. But for nums1, what is the minimum integer? 1. For nums2, what is the minimum integer? 2. Alright. For nums1, it is 1. So in nums1, I should check the second minimum. What is the second minimum? 2. Nums2 minimum 2. Oh, so I need to return 2 from here, right? So you're kind of getting this. Let me show you how we're going to do that. So we have 1, 2, 3, 6. This is nums1. And inside of nums2, we have 2, 3, 4, 5, right? Now, we'll take two pointers called I and j. So I will be pointing to the minimum element of nums1, which is at the 0th index, and j will be at 0th index, or would be pointing to the minimum element of the nums2 array. So this is what we are going to do. Now I know the arrays are sorted, right? I know the arrays are sorted. So if I simply take this pointer, right, what I'll do is first I'll check I'll be iterating until I is less than n and j is less than m. I will be iterating up to this point. So inside of a while loop. Then what I'll be doing is I'll be comparing are nums1 and nums2, nums1 of I and nums2 of j, are they equal? No. That means I have to move one pointer. Which pointer I have to move? I have to definitely move that pointer which has lesser value, because I want to match the values, right? So I want to match 2 with 1. So I know that this is the minimum value, right? It could be a solution. That means inside of this array, I need to find, is there a 2? So I have to move to the second minimum. So I'll move my I pointer. I'll move my I pointer here. So here I would get the answer. So then again, we'll do another iteration and check, are nums1 of I and nums2 of j matching? Yes, then simply return true. Now let's say you traverse the whole array here and here. Let me take another test case, okay? Let's say we have nums1 as 2, 3, 5 or 6, okay, and nums2 as 4, 7, 8 and 9. Now you can see there is no common integer, so I must return -1. So how am I going to do this using this loop, right? So I'll have while I less than n and then j less than m, and here is my I pointer, here is my j pointer. Now I'll do what? I'll compare both of these. So obviously 4 is greater, so I have to move my I pointer in that case. So I'll move my I pointer here and again compare. Again I is lesser, I'll move my I pointer again. Then I'll compare 5 and 4. Oh, so 4 is lesser, so I'll have to move j pointer to check if 5 exists in nums2. Okay, they are again not equal, so 5 is lesser, so you'll move your I here. Then again I is lesser, so now you cannot move your I, so you'll exit out of this loop. And then as soon as you exit out of this loop, you have to return -1. That means there was no common value that you found, because you exhausted all the values in nums1, or you might have exhausted all the values in nums2. So if you have exhausted all the values and you didn't find a match, that means there is no match, right? So return -1. Let us take another example, okay? Let me take nums1 as 2, 3, 5, 6 and nums2 as 4, 7. Okay, 4, 7 would be large. I'll take it as 1, 4, 6 and 7. Okay, so these are the arrays that we have. Again, do the same thing. Initialize 2 pointers, I, j, pointing to the minimum value of the nums1, nums2, both, right? Then, now, iterate in this, right? So what is the condition here? The condition is you have to check if nums1 of I equal nums2 of j, right? Return that particular integer then and there. Else if check which one is lesser. So right, let's say nums1 of I is lesser than nums2 of j. That means you have to move I pointer, because you have to make it equal to the j pointer, right? And then else you have to move your j pointer. So these are the 3 conditions that you have to do. Let us do according to that. I, j. Now you can see that they both are not equal. What do you have to do? You have to move one pointer. Which pointer? So here you can see that if nums1 of I is less than nums2 of j, which is not true. Nums2 of j is lesser. So that means you'll fall under this one condition. And what you'll do, you'll move your j pointer to here. You moved your j pointer. Then again check for I and j value. So 2 equal 4. No. 2 is less than 4. So you will move I pointer. Okay. So 3, 4. Are they equal? No. And 3 is lesser. And I have to match this value 4. So I have to increase my ith pointer. And now 5 and 4, again they are not equal, so which one I have to move? I have to move j pointer. Again check j and I, are they equal? No. So move which pointer? Ith pointer. Now you can see that ith and jth pointer values are matching, which you need to return. So this is how you're going to solve this question, and I hope you are getting what we are doing, right? Now with this approach, you are essentially iterating only minimum of n comma m, because you will exhaust one of the array, right? Let's say there were only 3 elements in nums1 and 4 elements in nums2, right? So you will only iterate up to 3 elements, right? and that also in the worst case that you don't have any common value. So the time complexity is going to be big O of minimum of n comma m, and your space complexity will be big O of 1, which is constant space. So this is the most optimized way you could solve this question, right? So I hope you are getting. Now let us go ahead and quickly see the code, although the code is written completely here only, but yeah, let's see here also. So, as I said, we'll take two pointers I and j. Both are at 0th index. So, 0 index means the minimum value of the both arrays. Then, we have also taken the size of the arrays nm, and we are iterating up to I less than n and j less than m. And we are checking if the values are equal, simply return that value, right? And otherwise, whichever is the smaller, move that pointer because you want to match a value. You are finding a common value, right? And and for the vice versa, right? If let's say nums2 of j is lesser, then move the j pointer. Otherwise, after this while loop, either you would have exhausted one of the arrays or you would have found the value, right? So if you have found the values, you would have already returned. But if there is no common value, you have to return -1, because by that time you will exhaust one of the arrays. All right. So that is it for this question. I hope you understood it.